My name is Madison Jackson, and for Lab 11, I decided to redo Lab 2, which was the beam strain gauge lab, but instead of using a cantilever beam, using a simply supported beam. For the setup, as you can see on the left side of the picture here is the Wheatstone Bridge. That is the exact same setup as for Lab 2, and the beam this time has one support on either end. Unfortunately, I was unable to use the clamp as we did in the previous lab because that would have required pushing two of the lab stations together, and that was unable to happen, so I just used these two wooden blocks as you see here. And in this video, it just shows collection of unloaded beam data in which there are no coins or anything placed upon the beam. Next, I used 2/4 in the very center of the beam, as you can see here. Instead of doing 5 trials for each, I just had 2/4, 4/4, and 6/4, and then 2 trials for each. So 6 data sets for those, and then your unloaded data, so 7 in total. And this video here shows the 2/4 data collection. And then the same thing for 4/4, still stacked in the center of the beam. And then finally 6/4. Apologies for the noise in the background. Someone was doing their Lab 6B, taking their Lab 6B data while I was performing this experiment, so apologies for the noise. For the data analysis, a lot of it was the same as it was for Lab 2. However, you were unable to use the same deflection equation as you were for a cantilever beam with a load on the end. You had to use this equation shown here on the left for the center of a simply supported beam, where the source is in the Lab 11 manual, source number 1. And that is deflection equals force. L2 is halfway down the beam. And then instead of 3 EI, it's 48 EI. And then on the right is that equation, but using the same derivation techniques as before to get it in terms of the strain. Finally, we get to the plots. As you can see here, unfortunately, the data didn't work out very well for me, especially because, as you can see from the stress versus strain plot, it has a negative slope, and that's impossible for a modulus of elasticity. So this could have been caused by the DAC itself, because halfway through recording data, it just decided to stop plotting anything, and then I had to unplug it. That didn't help. I reconnected it. I closed MATLAB. That didn't help either. It started working again after I had closed MATLAB down for a second time, so it could have been an issue with that. Or also the setup that I had with the 2 blocks that I was unable to do with my original plan, which was to have the clamps on either end, but since you need to move the entire lab setup, didn't really work out. And then deflection plot is also very off.